In this simulation, we will explore hydrogen in the reactivity series. Do you know what happens when magnesium metal is added to a dilute acid? Let's watch this video and remember together. So we added magnesium with dilute sulfuric acid. Notice the air bubbles produced and the change in color. How could you show that the gas given off was hydrogen? In other words, what's a test for hydrogen gas? Lime water turns milky when the gas is bubbled through it. The gas burns with a pop when a lighted splint is applied. A glowing splint will relight when plunged into the gas. The gas bleached damp blue litmus paper. Which of these is the test of hydrogen gas? Excellent. The gas will burn with a pop when a lightened splint is applied. If the gas produced was carbon dioxide, then it will turn lime water milky. If the gas produced was oxygen, it will relight a glowing splint. And if it was chlorine, then it will bleach damp blue litmus paper. However, in a reaction between metals and acids, the gas produced is hydrogen gas, which will burn with a pop sound when a lighted splint is applied. Here's the equation for the reaction between magnesium and sulfuric acid, which will produce magnesium sulfate and hydrogen. Magnesium, which is solid, will react with H2SO4 aqueous to produce magnesium sulfate MgSO4 aqueous plus H2 gas, hydrogen gas. In this reaction, the magnesium displaces the hydrogen from the solution of sulfuric acid. So magnesium will take the place of hydrogen. At the reactant side, hydrogen is bonded to SO4. Now magnesium will take the place of hydrogen. So at the product side, we will obtain MgSO4. Now magnesium is bonded to SO4 and we have hydrogen gas H2. What does this reaction tell us about the reactivity of magnesium compared with hydrogen? Hydrogen is more reactive than magnesium, or magnesium is more reactive than hydrogen? This equation shows that magnesium displaces the hydrogen. So yes, this means that magnesium is more reactive than hydrogen because a more reactive metal will displace a less reactive one. What would we see if we placed a metal that's less reactive than hydrogen in a test tube containing some dilute acid? Keep in mind that a less reactive metal than hydrogen won't react with it. Excellent! No reaction will take place if we place the metal that's less reactive than hydrogen in a test tube containing some dilute acid. Actually, slight fizzing on the surface of the metal will be observed if the metal is of similar reactivity to hydrogen. On the other hand, vigorous fizzing on the surface of the metal with metals of high reactivity, whereas less reactive metals than hydrogen won't react with it, so no reaction will be observed. Let's take a look at this table. We have three groups of metals. In the first group, we have calcium, magnesium, aluminum, zinc, and iron. When added with a dilute acid, we will observe fizzing or effervescence and giving off hydrogen gas. Whereas, if we use tin or lead, hydrogen will be given off very slowly and the reaction will be faster if the acid is heated. If we use copper, silver, or gold, no reaction will take place. So if we want to classify these metals based on their reactivity, we will find that the first group, which is calcium, magnesium, aluminum, zinc, and iron, are of high reactivity, and this is because a vigorous reaction took place. We observed fizzing and giving off hydrogen gas. Whereas tin and lead are of similar reactivity to hydrogen, and this is because hydrogen was given off very slowly. while copper, silver, and gold are less reactive than hydrogen because no reaction took place. From the data presented over here, which metals in the table above are less reactive than hydrogen? Excellent. Copper, silver, and gold are all less reactive than hydrogen because they cannot react with dilute acid. The table shows us that copper isn't reactive enough to displace hydrogen ions from solution. However, lead can displace hydrogen. Actually, the metals in the table above are listed in order of their reactivity. So hydrogen could be slotted into the reactivity series between lead and copper. This is hydrogen. Hydrogen is more reactive than copper but less reactive than lead.